Welcome back. So today is part 2 of 8.1. So we're actually going to be using these two sheets. So we have the word problems, doodle notes, as well as the area of similar polygons foldable. So we're going to be starting with the doodle notes. So if you want to go ahead and take those out first. So we're going to be doing some word problems dealing with our similar shapes that we were talking about in the first video. So for this one, it says that we have a 4-meter tree casts a shadow that is 15 meters long. How tall is another tree that casts a shadow that is 20 meters long? Okay, so I'm actually going to draw a picture in order to show this. So we've got one tree that we know is 4 meters tall. It casts a shadow that's 15 meters long. And we're going to connect this to make a triangle. So these are going to be similar triangles. So then the next one says that we have this other tree. We don't know how tall it is, but it casts a shadow that's 20 meters long. So we're going to put the top on our tree there. Since we don't know how tall, that's where we're going to put our X. And then we're just going to connect. So there's our two pictures. So if you remember when we talked about setting up our proportions in the first video, we said you have to have your corresponding parts. So for this one, our corresponding parts are the height of the tree. So that's going to be 4 over x equals our shadow's length. So that's going to be 15 over 20. Okay, so now that we have our proportions set up, we're going to cross multiply. So we have 15x equals 4 times 20. So we're going to simplify the right, and we get 80. On the left, we still have our 15x. So now we're going to divide by 15 on both sides and get x equals 5 1/3. Okay, if we reduce this down, we would end up getting 16 over 3. And so that's why we have 5 1/3. Since that decimal repeats, we're going to leave this in fraction form because we don't want an approximate answer. We want to know the exact answer. All right, so since this was a word problem, we're going to write a sentence for our answer. It asked us to find how tall is the tree. So we found the tree is 5 1/3. This is meters tall. So we're just writing a very simple sentence there to give some context to that number that we just found. Okay, let's go ahead and move on to the next word problem here. So now we're dealing with a flagpole. So again, I'm going to draw a picture. It says a 50-foot flagpole casts a 20-foot shadow. I'm going to draw a nice tall flagpole here. And then it's kind of short shadow. We're going to label those 50 feet and 20 feet. Okay, and then the next part says that we're going to find the shadow cast by a nearby soldier that is 6 feet tall. So we've got a little soldier here casting a short shadow as well. He is 6 feet tall. We don't know the length of his shadow. That's what we're trying to find. So we're going to put X there. So again, we're going to set up our proportion with our corresponding parts. So we have the height of the flagpole is 50. The height of the soldier is 6. Equals the length of the shadow is 20 over the length of the shadow is X. From here, we're going to cross multiply. We get 50x equals 6 times 20. So now we're going to simplify that. 6 times 20 is 120 equals 50x. Divide by 50 on both sides. And we get x equals 2.4. This time we can have it in decimal form because this is a terminating decimal, or it's a decimal that stops. It doesn't go on like the one did up here. So for this one, I'm going to have it in decimal form, and then we're going to write our sentence. This is the length of the shadow. So the shadow is 2.4. This is feet. long. So again, just a very simple sentence there to give some context to what it was that we found. All right, so for this next part, we're going to be down in the challenge. So for this piece, I'm actually going to be writing this on a separate piece, just so it's a little easier for you to see what I would put up here in this box. So it says triangle ABC and DEF are similar. The perimeter of the larger triangle ABC is 56 centimeters. The length of the two corresponding sides is 9 and 24. What is the perimeter of DEF? Okay, well, first we need to talk about perimeter and how that works with similar polygons. So we're going to write a definition here. So we have perimeter ratios are proportional to side ratios. So what that means is when we know the ratio of the sides, like we did up here, then we can use that same ratio equal with our perimeters. Okay, and so we can set up that proportion and solve just like we were doing before. Okay, so again, we're going to start out with a picture. So we've got ABC, said was bigger than DEF, so I'm going to draw a smaller one over here, DEF. We have perimeter for ABC is 56. And we don't know the perimeter for DEF, so I'm going to put an X in there. Okay, and then it also told us some sides, a 9 and a 24 are corresponding sides. So that means the smaller number has to go with DEF, so that would be my 9, and my 24 goes over here with my larger. All right, so then from here, we're going to set up our proportion. So I need to have my corresponding parts. So we said first, we had that 9 and 24 were corresponding sides. Then the next one is going to be our corresponding perimeters. So with the 9 is the X, with the 24 is the 56. So now that we have our proportion, we're going to cross multiply and solve. So we have 24 times X equals 9 times 56. So we're going to simplify what we have over here on the right, and that's going to be 504. So we have 24x equals 504, dividing by 24 on both sides. We end up with x equals 21. So again, we're going to write a sentence to give some context to what that number really represents. And it says find the perimeter of triangle DEF. So the perimeter of triangle DEF is 21, and our label here is centimeters. Okay, all right, so that's all I have for this side. So now we're going to actually move on to your foldable, which is the area of similar polygons foldable. So for this one, first we're going to open up that top flap and actually have a theorem for you. So our theorem says if two polygons are similar with the lengths of corresponding sides in ratio A to B, then the ratio of their areas is A squared to B squared. Okay, so if you need to pause the video to go ahead and get that written down, now would be a good time to pause it and then come back when you're ready. All right, so now that we have that written down, we're going to move on to the next piece. So go ahead and open up that next part there. Now, typically we don't have it written with a colon when we're working with it in a proportion. So we're going to write these in fraction form. So side to side is A to B. So that's A over B. If we're looking at area, that's going to be A squared over B squared. Okay? So now we're going to do some examples to work with area. The first one, example 1, slide this up just a little bit here. So for example 1, it gives us the length of side AC and XZ, and it asks us to find the ratio of the areas. Okay, so first thing we're going to do is we're going to set up the ratio of our corresponding sides, which is 5/8. And then it said for area, we're going to take that ratio of our sides and we're going to square it. So we're going to take 5 squared and 8 squared. 5 squared is 25. 8 squared is 64. So the ratio of our areas is 25/64. Okay. The next one that we're going to do, we're actually going to slide down here a little bit to example 2. This time they gave us the areas and they're asking us to find the ratio of the side lengths. So this is very similar. So this time we have a squared over b squared equals our areas, which is 28/63. Now, if I was trying to figure this out, I know that a squared would have to equal 28. I know that b squared would have to equal 63. So in order to find a and b, I would have to do the square root. Well, 28 and 63 are not perfect squares, so we're going to get some kind of a decimal answer. So instead of doing the square root with those numbers, I'm actually going to simplify my areas first. And so when we simplify those, we're looking for a number that both the 28 and 63 have in common. So I see we have a 7 in common with both. If I divide by 7 on the top and divide by 7 on the bottom, I end up coming up with 4/9. 4 and 9 are perfect squares. So now I'm going to set up two different equations here. We have a squared equals 4, and I have b squared equals 9. So I'm going to take the square root of both, and we end up with a equals 2 and b equals 3. So the ratio of our sides is 2/3. Okay? All right, so let's move on, and we're going to do example 3 here where we're finding the area for a polygon. So looking at example 3, they gave us 2 side lengths and 1 area. So we're going to be setting up a proportion this time. We're going to start with our side lengths. That's 12 and 15. Those are our corresponding sides. And since it's going to be equal to an area, we know that we have to square those two pieces. Okay, so we're going to take 12 squared and 15 squared. You could have simplified this fraction first, but I'm just going to work with it as it is. All right, so then I'm going to put my areas. So 12 squared, that one goes with an area of x because we don't know what that one is yet. So I'm just going to put an x up here. The 15 squared goes with the 325, so we're going to put 325 on the bottom. And then we're going to simplify these exponents. So we have 12 squared is 144. 15 squared is 225. And then we still have x over 325 on the right. From here, we're going to cross multiply. We get 225x equals 144 times 325. So I'm going to simplify the right. This is 46,800. On the left, we still have 225x. So then from here, we're going to divide by 225. And we get x equals 208. Now what does that 208 represent? So we're going to write a little sentence. So they asked us to find the area. So we're going to say the area of ABCD is 208 centimeters squared. Okay, again, just a very simple sentence. All right, let's do one more. This time they're giving us the two areas and only one side. They're asking us to find one of the sides. They gave us CD, and so in order to have corresponding pieces, we're going to change this KL and we're going to find ML. Okay, so just please change that on your notes to ML. All right, so for this one, we're going to do the same thing as what we were doing over here, but now we have a different missing piece. So I'm still going to start with my sides. I've got 27 over x. We have to square those since we're going to be setting it equal to areas. So 27 squared, x squared equals, with my 27 is the 162, and with my x is the 8. Now that we have that set up, we're going to simplify the exponent. So the 27 squared is 729. So this is 729 over x squared equals the 162 over 8. Then we're going to cross multiply. We have 162 x squared equals 8 times 729. Simplifying the right, 8 times 729 is 5,832 equals our 162x squared. Divide by the 162. We end up with x squared equals 36. We still need to find x. So to change that square root to just, or excuse me, instead of x squared, we're going to do the square root so that we get just x. So the square root gives us x equals 30, or excuse me, x equals 6. The square root of 36 is 6. Okay, again, we're going to write a really simple sentence to give some context to our 6. So we were finding ML. So the measure of ML is 6 inches. Okay, all right, that's all that I have for you today. Go ahead and finish the practice problems that go along with this, and I'll see you in class. Have a great day. Bye.